In our quest to understand the world, modern physics has given us clues that the universe may not be all there is. There may in fact be many universes, a multiverse. And not just one multiverse either, but many different types of multiverse. There are several classifications of multiverse you'll find if you do a Google search. One is Max Tegmark's 4 levels, but since I don't like to think in terms of hierarchies, we'll do Brian Greene's 9 types instead. And then, to avoid repeating what you can hear a million other places on the internet, I'm going to tell you why all of them are boring. Going off the list on Wikipedia, the first type of multiverse is the quilted multiverse. This can be considered either a multiverse or more of the same universe. We live at the center of our observable universe. That is the region of space light has had time to reach us since the Big Bang. And although the observable universe has a size, we have no evidence that the actual universe stops anywhere near there. If you think about it, every point in space is the center of its own observable universe. And so you can imagine 2 volumes of space that are completely separate that light has not had time to travel between. These would be separate universes. You might think we could reach those places one day as the universe gets older and light has time to travel from further and further distances. You'd imagine that those universal volumes would grow until they overlap. But the problem is that the universe is expanding, and these volumes that are outside each other's horizons are expanding away from each other faster than the speed of light. So no matter how fast we go, or no matter how long we wait, we'll never be able to reach them. So it's fair to simply call it the universe, or a multiverse with many observable volumes. This is one of 2 types of multiverses that we are certain exists. All the rest have about 50-50 odds. The second type of multiverse is from inflation. What is inflation? It's an answer to the horizon problem. Why are the different sides of the universe homogeneous with each other? Okay, what does this mean and why is it a problem? Well, it's like there's an enormous pot of coffee with cream in it. And the question is, why is the cream evenly mixed when the speed of the cream is slower than the expansion of the coffee? Inflation proposes that the cream was already mixed in that initial drop of coffee when it first exploded. Inflation, particularly eternal inflation, is a hypothesis about what physical reality was like before the Big Bang. In the time before time, space was expanding so fast that a volume the size of an atom would expand to the size of a grapefruit in a nanosecond. Then a quantum event randomly happened. Which it does, that's how quantum physics works. A small volume of space slowed its expansion from the inflationary rate to something close to the universal expansion we know today. A seed crystal of space within inflation from which our universe grew. If this is true, it would mean our universe has an edge. But we could never reach it because that edge would always be receding from every point inside the universe faster than the speed of light. It would also mean that beyond that edge, there is still inflation, and within that inflation, many other universal seed crystals pop into being. An eternally renewing multiverse, with universes that are just being born and universes that are unfathomably old. Third, we have the Brane multiverse. And to any string theorists watching this, you should have called it membrane so that we don't have to tell everybody every single time that we're not talking about this kind of brain. String theory describes the universe as interactions between objects of different numbers of dimensions. A particle, as classically conceptualized, would have 0 dimensions, a single point. It would be a zero brane. String theory models them as one-dimensional strings, one branes. Our universe with its 3 dimensions could be a 3-brane within a higher dimensional space called the bulk. And within that bulk, there could be many more membranes, universes, with various numbers of dimensions. And we could theoretically get to them if we could travel through those higher dimensions. Also, when they collide, they cause big bangs. So let's hope we don't run into our neighbors anytime soon. Next, we have the cyclic multiverse, which suggests that new universes are born from old universes. This could be when a universe dies, such as in a big crunch or a big rip, or after an infinite amount of time, like in conformal cyclic cosmology. Universes may also birth child universes without dying. It could be, for instance, that the inside of a black hole, instead of leading to a singularity, is another universe. Next is the landscape universe. String theory provides a potential unification of all theories of physics. The problem is, it requires 10 dimensions of space plus 1 of time to do it. The question of string theory then is, why do we only see 3 dimensions of space? Where did all the rest go? The theory is that they're all curled up very small. What does that mean? Well, the standard analogy is that you have an ant walking along a wire, and from far away the wire looks one-dimensional, but from the point of view of the ant, it's two-dimensional. Except that analogy doesn't work very well because when you actually get close to the wire, it's not two-dimensional, it's three-dimensional. I prefer to think of it like Pac-Man. You go off one side and you come back on the other. If there's one dimension to curl up, there's one way to do it. You make it into a loop. 2 dimensions can be curled up like a sphere or like a torus. And perhaps there are more ways, I'm not quite sure. And as you can imagine, as the number of dimensions to be curled up increases, the number of methods to curl them up explodes to near infinite. The reason this is important is because different methods of curling up dimensions lead to different physical laws. And perhaps all those different methods exist, leading to another multiverse. Next is the quantum multiverse. And I did a whole series on quantum physics, so if you want a more in-depth discussion, you can check out that playlist. Here's the gist. Individual particles and small groups of particles can be in superposition states. This means that they can technically exist in different contradictory states with different probabilities at the same time. So the question is, why aren't large numbers of particles, like human beings, in superpositions of contradictory states? The quantum multiverse says we are. There's no such thing as a measurement. Wave functions never collapse. Thus, every time a superposition gets amplified to macroscopic size, the universe splits. At this point, the only evidence of a quantum multiverse is using Occam's razor on the math, which is not a bad technique, but it's not proof by any means. Next on the list is the holographic multiverse. I don't know why this is on the list because it's not a multiverse. It's the observation that anything in a 3D volume can be encoded on the surface surrounding it, which is mind-blowing, but it's not a multiverse. It's a math trick to try to describe what happens to information when it falls into black holes by suggesting that it gets printed on the event horizon. Also, when I was searching for info on the holographic multiverse, all I found was New Age bullshit using scientific language to capitalize on naive minds. As they do. Next is the simulated multiverse. This is the second type of multiverse that we know exists. Wait. We don't know that the universe is a simulation. It's just a hypothesis, and not a very good one at that. Well, it's complicated and interesting and maybe worth its own video. The reason I say we know this multiverse exists is because we've built it. We run simulations on our computers all the time. Voila! Simulation multiverse. Okay, maybe that's not the multiverse we were thinking of, but it's a proof of concept. If computer technology continues to improve for millions of years, then we can expect our descendants to be able to simulate worlds that could be considered universes, even populated by conscious beings, which are not in virtual reality but are themselves coded into the software. Even if you object to the idea that minds can run on our current computer technology, we know that consciousness exists, therefore it's physically possible to build it. Then we come to the 9th multiverse, the ultimate multiverse, the set of all possible universes that can be represented by consistent mathematics. As someone who believes math is invented, not discovered, I'm not sure what to make of this idea. If something couldn't be described by math, we'd come up with new math to describe it, like we do all the time. Perhaps the ultimate multiverse is Brian Greene's version of the omniverse, the set of all possible realities, physical, metaphysical, conceivable, inconceivable. which is of course just a philosophical idea and not something that actually exists. Most likely. Incidentally, while researching for this video, I came across a wiki called Verse and Dimensions, which goes into all kinds of crazy ideas like the omniverse, the imaginarium, and super reality, inspired by comic books, I presume. So if that kind of thing tickles your brain, there will be a link in the description. Just remember, it's purely philosophical. So now that we've gotten through the 8 multiverses, I'm going to explain why all of them are boring. Now you may be saying, Chris, multiverses aren't boring. And I admit that when we talk about multiverses, they get our brains tingling. But the reason it's cool is because it hints at the meaning of life, the universe, and everything. And the reason it's boring is because it doesn't deliver. What is it we want from a multiverse? Our fiction can tell us. In our stories, multiverses are not about spaces where the laws of physics are different, or where this particle was found over here instead. They're about us, alternate human histories. What would life have been like if the Soviets had won the Cold War? Or if you had become a pilot instead of a construction worker? Or if we had found a way to save our friend's life? These are the parallel universes that are interesting to us. What would your life and my life have been like if things had taken a different course? In the vast majority, when sci-fi uses multiverses, it's to explore a question like this. And with the possible exception of the simulated multiverse, none of the 8 physical multiverses provide this. If someday we develop the technology to travel to other universes, we'll find that either nothing noticeable has changed, or all is incomprehensible chaos. Oh, alternate histories would exist, but any real multiverse would be sorted by physics, not human significance. And the chance of you running into one where you made that other decision would be about the same as the chance of phasing through the floor due to quantum tunneling. Despite the science in science fiction, it's not really about science. It's about how science and technology affects us. The reason Star Wars uses lasers is not to show off stimulated emission, even though that is a wicked cool effect of quantum physics, but to show what it's like to wave spears in support of our tribes when those tribes are powerful enough to blow up planets. The reason Back to the Future uses time travel is not to wax philosophical on the entropic arrow of time, but to make us laugh with the juxtaposition of cultural time periods and dramatic irony. And the reason Star Trek uses a multiverse is not to teach models of physics, but to explore what would happen if everyone were evil. Physical multiverses range on how far they deviate from ours, from a few misplaced particles to completely different laws of physics. But none of them are useful for what might be different in our personal lives, our history, or our culture. So I'm going to add one more multiverse to the list. The What If multiverse. In this multiverse, the universe splits anytime a significant event happens. Most events, like what to have for breakfast, are soon forgotten, and those universes merge together again. But anytime a choice or event has a significant effect from an individual to the course of history, those universes remain split. This is the universe where we can find copies of ourselves living slightly different lives, and where if we search far enough, we'll find the one where you are Batman. There is no physical theory that suggests a what-if multiverse might exist. But if fiction, religion, and spirituality have taught us anything, a thing doesn't have to exist to be valuable. When we add the what-if multiverse to our list, taking the place of a holographic multiverse, the number rises again from 8, a number which feels incomplete, to a more cosmologically satisfying 9. Thank you for watching. I'll see you next time.